Okay, this is an interesting problem. It looks just like the others. The author intends for you to use r and theta for this, but let's go through, first of all, let's determine if I can do this problem. So how many degree of freedom is it? The answer is 1, because if this peg is free to move up and down, if you stop it from going up and down, then when the red peg stops, then this bar here can't move anymore because it's stuck with that red peg. So this has 1 degree of freedom. What that means is if you give me one angle, I can find any angle you want. You did. So I can find any distance, any angle, anything at all. So radius, I can find anything at all. The other thing is if you give me one single dot term, which you do, then I can find any single dot term, any velocity that you're interested in. If you give me one double dot term, which you do because you tell me that theta dot is constant, I can find any acceleration term. Okay, so what is it that they want me to find? They want me to find velocity and acceleration. Find the acceleration up here is so here part A, find the velocity, part B, find the acceleration. Okay, so if you want to, you can just blast through like you did all the others. You write down tangent normal. Is this a tangent normal? No, even though I know the path of the red spot, I don't really, and I know the radius of curvature, I don't have speeds, speed dots, things like that. So rule that out. It's not a tangent normal. So maybe it's an r theta. That's what the author wants you to do. But what I suggest in class is use a coordinate system that makes the acceleration as easy as possible. Well, if you think about it, the red dot is only going vertical. That's all it's doing. It's not doing something crazy. It's up and down. So why not choose x, horizontal, and vertical to be the directions that you want to use? That's what I'm going to do this time. You can, like I said, the author wants you to use polar coordinates, r and theta. But anyway, I'm going to show you how you can do it in a different way. Okay, if you want to find velocity, you need to say find an origin. So here's the origin. It's going to be a fixed point right down here at the bottom. It doesn't go anywhere. The position then is this distance right here, which I'll call y because everybody likes y to be the vertical thing. So I'm going to call that a distance y. That's a variable. So the velocity is equal to the derivative of the position. So the derivative of the position is y dot, and it's straight up in the j direction. So all I need to do is find y dot. I know I can because since it's 1 degree of freedom and because you're giving me one single dot term, I can find any single dot term you want. So what I'm looking for is a relationship between y, the variable y, because that's what I want, and the variable theta because that's what they tell me. So if you look at this for a little while, the one I come up with is the following. The tangent of the angle theta is equal to y divided by 4. And the reason I use that instead of a hypotenuse, so you could, for example, write y is equal to the distance r, which is this distance right here, times the sine of the angle theta. There's nothing wrong with that except for the fact that theta is a variable, r is a variable, and y is a variable. Those are 3 variables. In this case, I only have 2 variables. I have y and I have theta. So it's much easier. But either way, just one's a little more work. Okay, so what I'm looking for is I'd like to solve for y. So y is equal to 4 times the tangent of the angle theta. And so if you want velocity, y dot is equal to, take a derivative of this. So that would be 4. The derivative of the tangent is, I've got to look it up, hang on. Okay, the derivative of the tangent is the secant squared of theta times the thing that is being taken, the tangent being taken out, so times the derivative of theta. So don't forget the chain rule, right? Does it satisfy the dot rule? Yep. So it satisfies the dot rule. Okay, so the velocity is this. You can just plug in. You know the angle theta is 30 degrees. So this guy here is 30. And this guy is 2. So you can take the secant square it, multiply by 2, bingo, you got the y dot. Take that number, you put it in right there, and that gets you the velocity. If you want the magnitude, that is the magnitude, right? So you got that guy. Now, in order to find the acceleration is the second derivative, or it's the derivative of velocity. So in that case, that would be y double dot straight up. So what you need to do is now find y double dot. Okay, to do that, I'm going to treat this like a product. So, well, first of all, I'm going to take the 4 out, but then this is the first term, and this is the second term. So it's the hate it when I keep bumping this thing. So anyway, it's the derivative of the first term times the second term plus the first term times the derivative of the second. So the derivative of the secant squared would be, you bring the power down times the derivative times the stuff being raised to a power to the power minus 1, so to the 1 power, times the derivative of the secant. The derivative of the secant is the secant tangent. So secant of theta, tangent of theta, times the derivative of what's on the inside of the secant. So the derivative of theta is theta dot. Okay, that's the derivative of the first term times the second term plus the first term, secant squared of theta, times the derivative of the second term. So using the product formula. Okay, so does it satisfy the dot conditions? There's 2 dots over here. The first term has 2 dots. The second term has 2 dots. So yes, it satisfies the dot things. So you just plug your numbers in here and pop it in right there, and you've got it. Now, if you're saying, oh, that's too hard, I'm going to do it with polar coordinates, well, that's fine. But what you're going to need is you're going to have to, first of all, you have to find, you're given the formula for R, you're going to have to take one derivative, and then you're going to have to take another derivative, right? And if you look at it, it's, what you're doing over here is going to be almost just as complicated, if not more, over here, because you're going to take the derivative of the secant, and you're going to take 2 of them, so you're going to end up expanding it out. So it's going to be as messy to do it with polar coordinates as it does, with the x and y. Plus, once you find your R double dots, you're going to have to, stick it into that big hairy formula for the 2 terms. Then you have to square each one, take the square root of it to find the magnitude. So if you ask me, using polar coordinates is by far harder. It's got more steps in it than to do it with the x and y. That's why in class, I'm telling you, always use the equations or the directions where the acceleration is the easiest to write. Okay.